direct variation. Okay. Or proportion.
Oh yeah, maybe Arsenal scored. Oh, sorry.
That was on video. Thanks, I'm gonna watch that back.
Okay. So if I said to you about direct variation or direct proportion, do you know what we mean? Anyone?
No.
Yeah.
Maybe that stretching and.
No, actually, no. We've moved on. No, I mean that could be included. Obviously, it's part. Everything's part of the same thing, but not quite. Not yet. No.
Okay.
So.
Do graphs.
Well, yeah, it can do.
Oh, I have an idea.
Yeah.
So you have like a shape, and then it says make the shape like by like times it by a half or something like the dimension or like.
So that would, yeah, you're getting a proportion thing. I think we're linking lots of things that you say, can say
Like
apply.
ratios?
Ratios could be, yeah, everything's linked. If I said P varies directly as Q. I've just made up some letters. It doesn't really mean anything. This is kind of like the vocabulary that we're using. And we kind of need to think about what does that mean. And if I gone,
That P is a variation of.
yeah, I guess we could say P is some kind of variation. But again, just to be specific, we're talking the relationship between P and Q. Okay. So, for instance, I could give you a problem like. It takes 1 hour for someone to read a sheet of paper.
Yes.
How long does it take them to read 3 sheets of paper?
Oh.
3 hours.
3 hours. Yeah. It takes, I don't know, 20 minutes for someone to mow a lawn. How long does it take them to mow 2 lawns?
Okay.
40 minutes. Yes, Greg.
So in that situation, would Q be the number of lawns and P be the time it takes?
Yeah, it could be. couldn't it? Yeah.
Okay.
Another one. So it takes 3 minutes to boil an egg. How long does it take to boil 2 eggs?
3 minutes.
Good, you didn't fall for that one. People going, what?
Unless.
Unless they're in
use a
different.
really small pen. Or you're.
We have to do one at a time, yeah. The other one is it takes 3 men an hour to dig a hole. How long does it take 2 men to dig half a hole?
The same amount of time because a hole is a subjective like size.
What's half a hole as well?
Yeah, exactly. So.
You can't dig half a hole. So sometimes these things can't. But in seriousness now, there are lots of things that vary directly, right? And you have done a lot of work on this with your functions, and functions basically show a relationship between 2 things. And we have linear relationships, we have exponential relationships, we have quadratic relationships. You've done all this before. But we can talk about whether something varies directly or whether something varies inversely. And that's what we're looking at, and whether they have a linear relationship or whether they have a non-linear relationship. Okay. So, and I think you were talking about the graphs and things. So, for instance, if I said to you, it takes, say 1 person can do, trying to make up, eat 5 hot dogs in a minute. All right. How many hot dogs could 3 people eat in a minute?
You don't know.
It depends. That kind of
Well, let's assume we maintain our proportions.
Oh, okay.
So one person eats 5 in a minute, 3 you'd assume takes 15. Okay. Now, if I asked you to display that information on a graph, what would it look like?
Maybe one long bar and then on a graph. Sorry, I thought you meant like a bar graph.
Oh, you make one situation the X and one situation the Y.
Yeah, so we could have, let's just think about one person takes 1 minute to eat 5 hot dogs. Okay. 3 people eat how many hot dogs in 1 minute? Okay. I mean, the next situation could be 10 people eat how many hot dogs in 1 minute? All right. So if I asked you to maybe say represent this whole situation using a graph, what would you say? Yeah.
Maybe like the y-axis can be number of people, and then the x-axis can be the number of
Okay. So there is a discussion to be had about which would be where. So what did you say again? Sorry.
the amount of people on the y and the amount of other.
So the amount of people and the number of hot dogs.
It would be time, not hot dog.
Well, what doesn't change? The time. So I would say they're right in saying time is not one of them.
I think that's the amount of people around the X.
And why would you say that?
Because you have 3 distinct amounts of people with a number of hot dogs, so there needs to be more like options.
Okay, but could I have more people as well?
Yes, but for this thing, I think it should be number of hot
Yeah,
dogs.
also the way I think like in science we were taught
Yeah,
is
go for it. Yeah, taught what?
um,
Do you remember which way round we would normally do it? So this would be the
independent variable. Yeah.
independent variable. Okay,
So how many hot dogs?
So the amount of people eating
and this
hot
is
dog.
the dependent. Yeah, so if you think about it as which one depends on which. And I like to do is when we talk scatter plots and things, I kind of like to say, you know, what depends on what. So it makes sense to say if there are 10 people, they would consume this many hot dogs. All right? So I will need more hot dogs the more people enter my competition, for instance, yeah? Let's say it's eating competition. Would I go down the route of saying, I've got this many hot dogs, that's how many people I need?
No.
That's not just, we could, but it's not really the right way about organising competition, is it? You figure out how many people you have, all right, because that's not under your, that's kind of like the independent variable, that's kind of, doesn't really matter how many people I get. What matters is how many hot dogs I need once I know how many people. So my independent variable will be the number of people, okay? And my dependent variable will be the number of hot dogs eaten, or needed in this case. All right, let's organise it. But what words the graph look like then?
So for
Yeah.
yeah,
Up and
it'll pretty much be an x.
It was Y, yeah.
up and
Not really.
straight.
Straight, yeah.
Okay. So we've got a linear relationship here, yeah?
Yeah.
Does it go through 0, 0?
Yes.
Yeah, does, because the relationship is 1 person, 5 hot dogs. No people? No hot dogs.
But one person, five.
5, so it's
So it's
y
like-
equals 5x.
like
Yeah,
X
there you
equals
go.
one, Y equals five.
So it'd be y equals 5x, no?
Plus 0. That's not needed.
What would you say
That's not
plus
needed.
0?
He's right.
Oh.
So we have y. So you can see how this relationship, we've got this linear relationship. And this situation, they always maintain that proportion, right? So I take the number of people and I multiply it by 5 to get the number of hot dogs I need. So this here, this 5, you will recognize it as the
S,
Gradient.
Or the M.
the m, the gradient. But when we're talking about this situation, we are also talking, as the constant of proportionality. So this is the thing that links the two variables.
Wait, so the graph will look kind of like this, right? Like very.
Yeah, exactly.
Wait, so that's constant proportion.
The constant of proportionality. Okay, so just that number, the 5. So I know that the relationship between x and y is times by 5.
What's that sign before the constant?
It's a cross out.
Oh.
It was a mistake. All right.
It's a long word.
Proportionality.
Yeah. It's almost as long as anti.
So we're going to go through a couple of types of questions. Are you ready, Nick? Sorry, I don't want to be rude. Really? I didn't know. And I'm right next to the computer and it's really loud and clear.
I love math.
So I'm going to go through an example.
So, like, this is always here. 100%.
Right.
Time.
It's always what? Yeah, so we have a constant of proportionality. We have the amount that links the two numbers. So we know that the number of hot dogs is always 5 times
One.
the number of people.
Well, time.
Yeah? And that's what links them. Right? Now, what we showed you was that is a linear graph. The 5 times bit is also, you recognise it as the gradient, so all those things are linked.
So the ratio of people to hot dogs is always 1 to 5.
Exactly.
Okay.
Yes, definitely.
So that's one.
That's another way to look at it as well. Yeah, link all these things together. Now, if I go through another type of question now, so we've got, I can say the variable y varies as x, right, directly. And we could say when x equals 4, y equals 10. So we've got that statement. And then we can say find the value of y when x equals 7.
So variable y varies at x or as?
So the variable y varies as x. Yeah, that should be as x. All right. So I might be able to introduce you to another little bit of notation as well. So I can rewrite this as y varies as x. That's how I would say it.
Oh, because it's like an A and an X.
It's kind of like a little fishy symbol. Yeah? But I guess, yeah, you can think it's y squiggly fishy thing. All right, so that means y varies as directly as x. Another way to write this, though, which is what you've just seen, is that y equals k times x. So this fishy symbol, the variation, the varies symbol, can be replaced with equals k. So we are looking for, if we are told that they vary directly, we are going to look for the constant proportionality. We're looking for that value that links the two. So the way we do that is by saying, well, I know that 10 equals something times 4.
2.5.
Okay. So K equals 10 over 4. Or we'll simplify to 5 over 2. I'm going to leave it as 5 over 2. Okay. I much prefer fractions. So then I can say that, well, y equals 5x over 2, because I've replaced the k. Right, so that is now the link. Right. Would that be a straight line too?
Yes, it would.
It would be a straight line. So now I can use that to find the value of y when x is 7. So I now know that y is 5 times 7 over 2, which is 35 over 2. So y equals, what did you say? 17.5. 17 and a half. Okay? So that's how we do it. Make sense?
Oh, yes, yes, that makes sense.
17.5.
So the y would be, and what we mean by this is that to maintain that relationship between x and y, we are told that there is a direct relationship. And when we say it varies directly, as you saw the graph, we're saying that if 4 increases, y will also increase. But it always has to maintain this proportional relationship in exactly the same way. And we're using that by saying, well, what is that link between the 4 and the 10? Right? And we found out that, well, 4 times 5 over 2, or 5 divided by 2, is equal to 10. So to maintain that proportion, I like what you guys were saying, the ratio, the whatever you want to call it, it is a ratio between the two to maintain that ratio. Right? So if you thought about it that way as well, so I think I liked what Ethan said. So I can say the ratio is 4 to 10. So I'm then looking at, well, if that's x to y, we've now got, it should be 7 to something. So how would you have done it using ratios?
Divide 7 by 4, and times 10 by 0.
Yeah. Divide 7 by 4. And times, does that work again? You want to try that?
7 by 4 and then times 10 by that.
Yeah. Well, if you think about it,
It's 1.75.
times 10, 17.5.
Wow, that's magic.
Because we could have actually gone down to, we can do, you've done ratios, I know you have because I've done them with my M2s and my M3s now. So I could have simplified this to 2 to 5, and even further to 1 to
2.5.
2.5, which is what we did here, look.
Oh.
So that's my K. That's the constant of proportionality. That's what the ratio would be if it was 1 to something. And you've probably seen that as a 1 to n. You've seen it written like that before? So now we multiply that by 7 to get the 7 to 17.5. So that link is there, that relationship is there. But we can do it now in this way. We can write it as a constant times x. All right? And that's becomes more useful when it's not just a linear relationship. All right? Now, I can either get you to get books out or I can just write a few questions. What should we do? Okay. So, just in case you refer back, this is on page 388. So, we've got variable v is directly proportional to t. And when t equals 5, v equals 40. Okay. First of all, well, basically what I want you to do is find V when t is 25. So that's one question. Okay, quick one then. I'm not going to do it the short way. Pay attention. V is proportional to t. That means that V equals k times t. So I can then work out k. We should always do that. Now you're either working out k or you're working out the ratio as 1 to k or k to 1. That's what you end up doing. Okay? So I think that's what I was hearing Greg do. Now this one's quite easy, but I'm still going to go through it. So I know that 40 equals k times 5, which makes k 8. Yeah? So that means that back here, V is 8t. So when t is 25, I've got V is 8 times 25, so V is 200. Now I think you already spotted with this nice and easy one that if t gets multiplied by 5, then this has to be multiplied by 5 to maintain that proportion. There's another way of doing it. But question 3, slightly different. But again, I would write P equals K times V. So I've got 8.64 equals K times 3.2. And I think we end up with K is 2.7?
Oh, yes. 2.
Just 2.
Because you're promoting.
True, yeah.
You have like 2.
But 2 times 3.2 is not... It is 2.7.
No, the answer is 2.
Yeah, K is 2.7.
Okay, good.
Yeah.
Right?
I was gonna say,
So now I can say, right, so because P is now 2.7V, if I use that over here, so I've got 5.4 equals 2.7 times V, so then you happen to get V is 2. A nice easy answer. Yes?
Is there, because I noticed you're using the KB way,
Yeah?
is there situations where you can't use the ratio to find it? Because I've been using like...
No, I mean, the reason why I pointed that out is because lots of people think, oh, I have to do it this way. If you understand that there's a link between proportions and ratio, I mean, that's what it's all about, isn't it? Ratios, fractions, you know. But what it might say in an exam question, it might say, write an equation,
Oh, okay.
right, that links these two. So, for instance, if I said to you here, not just find it, if I said to you, write an equation that links x and q, what would you do?
Y equals X.
No,
Q.
there's no y.
X equals KQ.
X equals kq. However, that is not a complete equation because we've got to find k to do that.
Oh, yeah.
All right. Now you would have done the same thing by finding, like I said, if you found the ratio 1 to k, then as long as you know, you put it in, fine. However you want to do it, but you have to know to do that. Whereas, I mean, it's the same process, isn't it? I would now go 4.7 equals k times 6.58.
Yeah, that's
K is 4.7 over 6.58, which is
1.4. Oh, no.
can't be, can it?
Yeah, no, never mind. But I found it.
Did you do the other way,
Yeah.
k to 1? And what's 4.7 divided by 0.7 exactly? And then
Yeah, that's why I did it the other way. Because it didn't give you,
what did it give you the other way?
1.4.
Exactly 1.4. Okay. So you can see sometimes working one way round or the other can give you answers that you don't have to round. Does that make sense?
Is it bad to round?
You'd prefer not to have to round, yeah.
Okay.
Alright? Because as soon as you start rounding, your numbers become slightly less accurate. Alright?
So would you get it wrong if
I
Or
got
what?
1.82.
Yeah.
But what if you?
No. As long as you don't round too much,
Yeah.
you're
You
fine.
could get unlucky and it would round to something different.
So what I could do, for instance, if I think I'm going to have to round, question mark it, well, we could actually just say, remember I said before, x equals 4.7 times q over 6.58 and just leave it like that. And then I'm sorted. And then when I want to solve the problems, I just put them in.
What if you put squiggly equal signs?
Yeah, I mean, but that's another way of saying I have rounded and it's less accurate.
Oh, true, yeah.
Yeah. That's all that's doing. It's not
That's
making
just
it
an
correct.
inaccuracy.
It's just saying I know I've done it.
Mm-hmm.
You know. Okay, makes sense.
Yes.
We're all right. Okay. Hurry up.
Now plug in the number. Maybe.
Right.
We have one more question.
13 point.
One more.
Guaranteed on the right side. Because it has Q.
Okay.
And then
Wait, how do you verify?
Uh-huh.
one, it's you see how this one is 2 containers of mass, soil is 1.6. You would make sure you like one of the ratios is 1.
Yeah, I'm just
So
so
you would divide
having it on the video.
the containers by 2, so it's 1 container, and that would mean it's 0.8 kilograms. And then you do that for the third one, so you divide that 3 by 3.